Again, a very warm welcome for today's session, day 18 of our bridge course. Okay, shall we start the class? Good morning, Santosh. Good morning, Vanilla. Good morning, Balakrishna. Good morning. Good morning to everyone. Danush, Keethna. Good morning. Darshini. Good morning. Sushruth. Good morning. Okay. Yeah. Kiranya. Good morning. Right. Okay, I think let's have a small recap of the last class. In last class, I have given introduction about chemical bonding. At the end of the class, I have given types of bonds. Okay, under that, I have given about covalent bond, ionic bond, coordinate covalent bond, metallic bonding, hydrogen bonding, and van der Waals bonding or forces I explained. Good morning, everyone. Let's start the class. Okay, shall we start the class? Before going to start the class, students requesting you guys to not spend time in chatting. Okay, it's better if you can focus on the class and follow the class properly. Okay, and don't be involved with unnecessary chatting. Don't be diverted and don't be distracted with the chatting. Okay, please focus on the class so that you can follow the class properly. You can be able to learn things in a proper manner and in a easier manner. Okay, fine. Today we will be working on mainly ionic bond, covalent bond and coordinate covalent bond, and we will try to work on the examples. Okay, so I told in last class, under strong forces I have given about ionic bond, then covalent bond. The third one is day 2 bond. And of course, the fourth one is metallic bonding. We are not going to study metallic bonding in bridge course. Okay, it will be discussed in future classes. We will focus on ionic bond, covalent bond and day 2 bond. Let's start with ionic bond. Let's try to define ionic bond. You know very well about ionic bond. Okay, ionic bond, it can also be called as electrovalent bond. In other words, in a shortest way, a bond between cation and anion. Or in other words, bond between positively charged species and negatively charged species. or it is the electrostatic force of attraction between oppositely charged ions. And other hint, majority of the cases, usually the bond between metal and usually the bond between metals and non-metals. When I refer usually, the majority of the compounds fall into this category. And when I am talking about the other version, you may come across the ionic bond between non-metals also, that I'll explain after completing the first version. So it is considered as electrovalent bond. It is the bond between cation, anion, or in other words, we can say cation is positively charged species and anion is negatively charged species. You can refer the bond between positively charged species and negatively charged species. Of course, if a positive charge and a negative charge is there, and we can expect the electrostatic force of attraction between oppositely charged ions. This electrostatic force of attraction is referred as ionic bond. The bond between usually metals and non-metals is considered to be ionic bond. Okay? And I can also say the bond which is formed by complete transfer of electrons. Bond formation is due to complete transfer of electrons. Right? Complete transfer of electrons. From you can also refer, if I am referring complete transfer of electrons, usually it takes from metal to non-metal. This is usual, this conventional definition. Okay. Let's try to illustrate the ionic bond formation with an example. Fine. Okay. Illustration example. Formation of, let us consider a simple example, NaCl. Then afterwards we will be moving to the another example after completing this example. I hope all these points are clear. Okay, right? So I have given the definition of ionic bond. I hope most of you guys will be able to recognize all these points which I have mentioned. I hope you knew already these points. Okay, right. Good. Okay, let's consider the formation of NaCl. Look at carefully. If I am talking about Na, it is usually metal, right? Sodium, which is normally existing in solid state. Okay, solid state. I have to explain in detail about the formation of NaCl. In detail explanation of NaCl is possible by giving some important definitions, because it relates with the idea about ionization energy and information about electron affinity. Okay, it's better after knowing the definitions about ionization energy and electron affinity, we will try to explain the formation of NaCl. So before that, let me explain in a brief way. Now, since sodium is a metal we know very well metal have electropositive nature. Metals usually prefer to lose electrons. That property is called as electropositive nature. Okay, sodium loses an electron and forms Na plus. Okay, fine. Sodium atomic number is 11 and its electronic configuration is 1s2, 2s2, 2p, 6 and 3s1. After removal of electron from 3s, if you write the electronic configuration of Na plus, the Na plus configuration is 1s2, 2s2, 2p, 6. We can connect this process with octet rule. Why sodium prefers to lose an electron? So what is need of giving out an electron from sodium? If you observe carefully, sodium is having only one electrons in its valence shell. As we know, this is first shell and 2, whatever, wherever this number 2 is representing or written is coming under second shell. This is K and this is L and this is M. The outermost shell is here M, and outermost shell or valence shell of sodium contains only one electron. If the sodium is able to give out its electron from the outermost shell, now the outermost electronic configuration of sodium became 2s2, 2p6. Now it is trying to have 8 electrons in its valence shell. Hence, sodium is achieving its octet. As we have discussed in last class, atoms are unstable. In order to stabilize them, we need to convert into bonding. I means atoms are unstable. In order to attain stability, they involved in bonding. As the sodium atom has only one electrons in its valence shell, if it can give out an electron from the valence shell, it is acquiring the octet configuration. Atoms, if they acquire or achieve octet configuration, we are presuming like they are attaining stability. Okay. Now sodium is safe when it is being converted from Na into Na plus. Okay. In the process of attainment of its octet, sodium is losing its electron. Okay. Sodium is losing its electron. This process we can also call it as electropositive nature. Of course, we will talk this process as ionization energy also. I'll explain in afterwards. Okay. Now, when it comes to the chlorine, if I am trying to take chlorine in atomic form, usually chlorine do not exist in atomic form. It is found in the form of Cl2 molecule. The entire process I will explain after just simple brief explanation about formation of NaCl. You need to have a basic idea about how NaCl is formed. But in detail explanation of NaCl formation involves various thermodynamic process. Okay. Now when it comes to the chlorine, the electronic configuration of chlorine is 1s2, 2s2, 2p, 6, 3s2, 3p, 5. If you observe the outermost electronic configuration of chlorine, it has 7 electrons. Okay. So chlorine has how many electrons in short of octet configuration? I mean to ask in this way, in order to attain its octet, chlorine has to have how many electrons? It has to have 8 electrons, but it is having only 7 electrons. What chlorine has to do in order to achieve its octet? Students, answer please. In order to achieve its octet, chlorine has to gain an electron or it has to lose an electron? It has to gain an electron. Okay, it has to gain an electron. So if it is able to take up one electron, it is trying to achieve octet configuration. Now the electronic configuration of chlorine became 1s2, 2s2, 2p6, 3s2, 3p6. If you observe the valence shell configuration of chlorine in Cl minus, it is having 8 electrons. Okay, sodium is achieving its octet by loss of electron. Chlorine is trying to achieve its octet by gain of electrons. Okay, now chlorine, if it is able to convert it into Cl minus, it is achieving its octet. Now we are ready with Na plus and we are also ready with Cl minus. Okay, how Na plus formation takes place? Sodium has to give out one electron. It is completely losing its electron. Its electron, the electron which is lost by sodium is transferred to chlorine. Now the chlorine became Cl minus by taking an electron which is given out by sodium. Therefore, the electron is being transferred from sodium to chlorine. So this is what I mean to say, complete transfer of electron. Here electron is completely transferred from sodium to chlorine. So the bond which is formed by complete transfer of electron is considered to be ionic bond. And other version of ionic bond, other definition of ionic bond also we will be talking about. Okay, we have positively charged species and negatively charged species. The force of attraction, the electrostatic force of attraction between oppositely charged species forms ionic bond. So this is electrostatic force of attraction. Okay, this electrostatic force of attraction is equal in all directions. Am I right? Equal in all directions. Hence, I wanted to conclude ionic bond is non-directional. You cannot specify the direction in a proper way. Okay, since the electrostatic force of attraction is operated in all directions, so oppositely charged ions have attraction in almost all directions with equal extent. That is the reason why you can conclude that ionic bond is non-directional bond, which is very, very important point. Okay, I hope this point is clear. Next, another point I wanted to explain. Fine. Systematic arrangement of these ions in 3 dimensions. Gives proper structure for ionic compounds, and which is termed as crystal lattice. What do you mean by crystal lattice? The systematic 3-dimensional arrangement of particles of ionic compound is called as crystal lattice. Crystal lattice itself is nothing but systematic 3-dimensional arrangement of oppositely charged ions of ionic compound. ionic compound. Let it be particles. Okay. I hope these points are clear. Okay. Is this point clear? What do you mean by crystal lattice? What do you mean by crystal lattice? Crystal lattice means systematic three-dimensional arrangement of, in the context of formation of ionic compound, we have ions. So therefore, systematic three-dimensional arrangement of oppositely charged ions of ionic compound refers lattice or crystal lattice. Okay. Next, last point I wanted to mention about the ionic compounds is molecular formula cannot be written for ionic compound. Okay, and can be with formula units or empirical formula. I have given three terms over here. One is molecular formula and second one empirical formula and the other one formula unit. As we know very well, in ionic compounds, if you observe, the smallest unit of ionic compound is considered to be formula unit. In case of ionic compounds, molecules will not be present. Okay, molecule story is for covalently bonded compounds. Molecule is the smallest particle of compound which exist independently. Here, ionic compounds do not exist like molecules. That is the reason why we won't write molecular formula for ionic compound. There is no meaning of molecular formula in the context of ionic compound. We can just refer the smallest or a single unit of ionic compound as formula unit. Ionic compounds can be written only with empirical formula. Empirical formula means the simplest ratio of atoms or ions in a given compound. Molecular formula refers the exact number of atoms present in a given molecule or compound. I hope these points are clear. Okay? Okay, so I have given mainly 3 or 4 important words under this space. I referred crystal lattice. I hope this point is clear. Crystal lattice means systematic three-dimensional arrangement of oppositely charged ions of our ionic compound. So, okay, Na plus and Cl minus should be distributed in three-dimensional way. That gives the proper structure for a given compound. That proper structure we can refer it as crystal lattice. We have various types of crystal lattice. Okay, that is not our context. Then the last point I have given, these ionic compounds cannot be written with molecular formula. These can be written only with empirical formulas. The simplest unit of a covalently bonded compound is referred as molecule, but the simplest unit of ionic compound can be referred as formula unit. That is the reason why for covalently bonded compounds we refer molecular mass, as I explained under mole concept. And ionic compounds we refer the mass as formula mass. For ionic compounds, smallest unit is referred as formula unit. For covalently bonded compound, the smallest unit is referred as molecule. Therefore, ionic compounds cannot be referred with molecular mass, or we can't write the molecular formula for ionic compounds. Ionic compounds can be written with only empirical formula. Okay. Do you know about the molecular formula and empirical formula? These will be discussed in our first chapter, first year course. In first year, we have a chapter named as Some Basic Concepts in Chemistry. Under this chapter, we will study about molecular formula and empirical formula. I hope I have given a brief idea about molecular formula and empirical formula also. Okay? Right? Let me give an example for illustration. So this can be easily illustrated by considering a molecule. Okay, if I am talking about glucose, what is molecular formula of glucose? Molecular formula of glucose is C6H12O6. And when it comes to the empirical formula is the simplest ratio of atoms. Simplest ratio of atoms. Okay. So if I am taking simplest ratio for this compound, what do we get? CH2O. I need to divide this with 6. Okay. 6 by 6, 12 by 6 and 6 by 6. If I am taking the ratio, you will be getting 1:2:1. Means carbon 1 atom must be present and 2 hydrogen atoms and 1 oxygen atom. I hope this point is clear. And when I am taking, let's say, benzene, let me take another example, benzene. Benzene, its molecular formula is C6H6. Its empirical formula would be, what is empirical formula of benzene? It is CH. Fine. If I am taking the context of, let's say, sodium chloride, it has assumed 6 units I have. Let us assume 6 units of, let me take, let's say 6 sodium ions I have and 6 chloride ions I have. I am not trying to deviate, okay? Okay. If you take in a particular unit cell, I refer it as a unit cell. Unit cell means smallest repeating unit of crystal lattice. Yeah, can anyone tell me? So it is not having any molecular formula. I can't write this as a molecular formula because it cannot be written with molecular formula. There is no single or independent unit of NaCl exist. Then we have to write only empirical formula. What would be the empirical formula of this unit cell? Okay, it is NaCl. This is referred as formula unit. I hope this point is clear. Is this clear? Is this clear? We will be moving on to the next point. Okay. So as I told, crystal lattice, the smallest repeating unit of crystal lattice is itself is unit cell. If you talk about one unit cell of NaCl, one unit cell of NaCl contains 6 Na plus and 6 Cl minus. If I take the ratio of these ions, you will get the formula unit as NaCl. Okay. I hope this point is clear. Let's move on to the next point. Next, I need to explain about electrovalency. Electrovalency. What do you mean by electrovalency? Electrovalency is the number of electrons lost by the metal okay, or if I refer a non-metal or non-metal, electrons gained by number of electrons gained by non-metal. Let us consider the context of example. If I refer formation of calcium chloride, if I am taking Tell me students, in formation of calcium chloride, calcium has to lose how many electrons? Calcium has to lose 2 electrons. As we know, the configuration of calcium is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. In order to attain the octet configuration, calcium has to lose 2 electrons. Now the configuration of calcium plus 2 becomes 1s2, 2s2, 2p6, 3s2, 3p6. Now the outermost shell of calcium is having octet. So in order to achieve the octet, calcium has to lose 2 electrons. The number of electrons lost by a metal during the formation of ionic bond is 2. Okay, so electrovalency of calcium is 2. So then what is electrovalency of Cl? Okay, if I am talking about each Cl, already I have written. Cl requires to gain how many electrons if I write the configuration in a short way with neon core? 3s2, 3p, 5, and now Cl minus configuration becomes neon 3s2, 3p, 6. In order to attain the octet configuration, Cl is trying to take or gain 1 electron. Therefore, electrovalency of chlorine Cl is 1. I hope this point is clear. So electrovalency means the number of electrons lost by either metal or the number of electrons gained by non-metal during the formation of ionic compound or ionic bond. Electrovalency of calcium here is 2 and electrovalency of chlorine is 1. Let me brief out a simple tabular form to recollect the electrovalency of various metals and non-metals. Okay, I hope these points are clear. Let's move on to the next page. Here I am writing first group elements. Over here I am writing 1A and 2A and 3A. Okay, here I am trying to write electrovalency, and if I am talking about 17th group elements 7A, and if I am talking about 16th group elements 6A, you can also write with the IUPAC convention, latest IUPAC convention, you can also write. This is nothing but first group, second group or third group, group number, and this is considered to be 17th group or 7th A, 16th group or 6A, 15th group or 5th. Right? We already concluded that the ionic bond formation takes place between metal and non-metal usually. Here I have given list of metals under first group, second group, third group, and I have given the non-metals under 17th, 16th and 15th group. The electrovalency of first A group or first group element is 1, since it's a simple point. Okay, for first group elements, it requires to lose 1 electron to achieve octet configuration. For second group elements, how many electrons need to be lost to attain octet configuration? It is 2. For 13th group element, 3 electrons are required to lose to achieve octet. Therefore, electrovalency of 1A group or first group is 1 and second group is 2 and 13th group, especially if I am talking about aluminum. Okay. Now, if I am talking about 17th group elements, 17th group elements have already 7 electrons in their valence shell. It requires to gain how many electrons? Only 1 electrons it required to gain. For 16th group elements, already 6 electrons, they need to gain 2 electrons to achieve octet configuration. If I am talking about 15th group, already 5 electrons are in the valence shell. They require to gain 3 electrons to achieve octet. I hope these points are clear. Electrovalency is the just number of electrons lost either by metal or by a non-metal. Electrons gained by non-metal. So can anyone tell me the electrovalency of aluminum and fluorine in AlF3 compound? Write the electrovalency of aluminum, electrovalency of underlined, let me write, of underlined element. I need electrovalency of aluminum and fluorine. In the same manner, I need the electrovalency of magnesium and chlorine over here. I need electrovalency of Pa okay. So what is electrovalency of aluminum over here? Answers please. Aluminum electrovalency is 3 and fluorine electrovalency is 1. Magnesium electrovalency is 2 and for chlorine it is 1. And for barium electrovalency is 2 because it is belonging to second group. And chlorine, as we know, electrovalency is 1. And what is electrovalency of cesium here? 1, it is first group, and bromine is 17th group. It requires only 1 electron to achieve octet. Sodium electrovalency is 1 and oxygen electrovalency is 2. Magnesium electrovalency is 2 and for oxygen electrovalency is 2. Okay. Then can anyone tell me what is electrovalency of aluminum and nitrogen? Consider if they are involved with ionic bond. Okay. Then what is electrovalency of aluminum? As we know, it is 3 and electrovalency of nitrogen is again 3. I hope these points are clear. I hope you are able to write the electrovalency of given element for a given ionic compound. Fine? Good. So with this we have completed ionic bond. Under ionic bond I have given mainly definition, and I have given information about the electrovalency, and we discussed about the crystal lattice, and we discussed about the identification of electrovalency of given ionic compounds. I hope you are able to write the electrovalency of given element for a given ionic compound. If you are able to recollect this table, you can easily identify the electrovalency of given element for a given ionic compound. Fine. Next moving on to the covalent bond. Students, are these points clear? If anyone has any doubts, you can ask me. You can ask me. Originally, I think earlier we have a solid state chapter in second year course, but that chapter was deleted. Under that chapter, we will discuss about crystal lattice, unit cells, various types of unit cells, various types of crystal lattice. So that chapter was deleted. Then we don't need to discuss about various crystal lattice. Okay, as I have mentioned, ionic compounds are possessing oppositely charged ions. These oppositely charged ions are arranged in a proper organized manner. This proper organized manner arrangement of oppositely charged ions gives crystal lattice. Okay, fine. Moving on to the covalent bond. Before going to discuss about covalent bond, I need to give other examples of ionic compounds. Can anyone tell me this compound is considered to be ionic compound or not. Okay, if I am taking, let's say, ammonium carries positive charge and then Cl carries negative charge. Okay, then what is the bond between ammonium and chloride? Here ammonium carries positive charge and chloride carries negative charge. These oppositely charged ions will have electrostatic force of attraction. Therefore, we can expect the ionic bond between ammonium and chloride ion. This is cation and this is anion. As we know, the bond between cation and anion is considered as ionic bond. Therefore, in ammonium chloride, we will find ionic bond. If you talk about ammonium chloride, there is no metal. Okay, this is if you consider group of atoms which are bonded through covalent bond only. Here NaH4, if you observe carefully, the bonds between nitrogen and hydrogen are covalent in nature. Okay, covalent in nature, and here ammonium as a total, it carries positively charged or positive charge, and chlorine carries negative charge. Even though group of non-metals are here, we can expect the bond between the positive charge and negative charge. Don't look at the non-metals over here. We need to check out the charges, positive charge and negative charge. We can expect the bond to be ionic bond. Okay, bond. Next, I need to explain next point. Someone is asking lattice enthalpy. I'll explain, don't worry. Lattice enthalpy, actually I told various thermodynamic processes have involved in formation of ionic compound. That is the reason why these points will be discussed in future classes, in regular classes. We don't have sufficient time to work on this. Anyway, you're asking what is lattice enthalpy. I'll define lattice enthalpy. If you consider an ionic bond, consider Na plus and Cl minus. Here there is force of attraction between Na plus and Cl minus. Okay. The energy, if you observe carefully, the energy which is required to break 1 mole of ionic bond. Okay. Right. Lattice enthalpy. Just brief discussion, brief idea about lattice enthalpy I am giving. The energy, the amount of energy required break 1 mole of ionic bond into its constituent ions in gaseous state. Or in other words, the amount of energy released in formation of 1 mole of ionic compound from its constituent ions in gaseous state. During the formation of ionic bond, energy usually released. This process is exothermic. In other words, if I am trying to break the force of attraction, or if I am trying to break 1 mole of ionic compound or ionic bond into its constituent ions, we require to supply the energy. Therefore, when you are breaking the bond, the process is considered as endothermic, and when you are making the bond, the process is considered as exothermic. Okay. Here, lattice enthalpy you cannot calculate directly. The lattice enthalpy can be calculated by using Born-Haber cycle. This will be discussed in regular classes. Okay. So I wanted to define once again, lattice enthalpy is the amount of energy required to break 1 mole of ionic compound into its constituent ions. Okay. So calculation of lattice enthalpy is based on Born-Haber cycle. It requires many thermodynamic process. We will be studying the calculation of lattice enthalpy by using Born-Haber cycle in future classes. I hope that's all for today's class. Thank you and have a nice day.